around 2006. Okay, so close to the end of my PhD study. Okay, so I start to look into the kernel and then find this list. Okay, and this list API is basically so shocked that I find that I don't know how to write C. Okay, after I read its code, I think that I don't know anything about writing C because it's using something really horrible things like you can see some of the syntax here. The syntax is like this, okay? So some define is here and is includes some keywords that you never seen before, type of, offset of, okay? And even doing some very horrible things, okay? So I just write it up last night, okay? And of course I already know how to use it for more than 9 years, okay? This is, we call it the generic data structure, okay? And every data structures in kernel is designed in such a way that it is generic, so that you can use it in any data type you create. Okay, we have linked list, and the extension of linked list, if you go to take a look at my repo contains the list.h here. Okay, when you click on it, the list.h, then you will find some definitions, quite long. That let's go to the bottom. Okay, go to the bottom, okay. Then you find another list called H list, okay. So what is this H list? I don't disclose to you, but actually this is the hash table list, okay. It is, if you know what is hash table means you hash something, but when we have collision, what should we do? We will concatenate it into a list, okay. So basically the hash table of kernel uses the same list, okay, but just rename it, call it H list. Okay, so you will find this kind of design also used in later, if we have time, we'll go to look at a Redback tree, the Redis tree, okay, many data structure that yesterday I shared to you. Okay, did you take a look here? I only see very few likes because I know that topic is so geeky. Okay, yeah. Some data structure of the kernel that use this kind of design. The linked list, the B tree is not generic. Priority sorting is generic. Redback tree is generic. Interval tree, I don't know. I never look at it. Redis tree also generic. Okay, so many generic design. Now today we will focus at what is generic design. Okay, and a generic design, the power is when you understand the design, then you can plug that list.h into your code and immediately become a very, very extensible list. Okay. Before that, let's take a look back on what happened last time. Okay. So last time I go to that room and contain another makeup class, so we don't have the time to explain everything. So, how many of you have go through all things? I mean, yeah, I look at the. Where is the, oh, here. I look at the post here, okay? So only very few people try this button, okay? Yeah, and some people already asked a good questions. There's no someone, okay? The good questions is about this. He asked, hey, this bug, okay? This bug code is actually will go to have a print. That definition will go to have a print K and eventually have panic. Okay, so what does that mean? That means that if you call bug, that it's basically it's going to panic. Now, I don't know whether you know about this. Okay, what is this symbol in 947? If not defined. Okay, so it's a compile time thing. It's a compile time thing. If you have a code, when it compile, you have, I don't know where, but there is a file, say not just header file but C file also. Define this guy. Okay, define have architecture bug. Then this part, okay, is if not. So if you have it, then we will don't have it. Understand? Yeah. So it depends on whether our architecture has defined this or not. Okay. So then in my reply, I said, this is hard to see. Where's my reply? Okay, so my reply is yeah, it boils down to the definition of this guy. Okay, but I put the asterisk here because we may have a but or but on definition. So if you want to know more, you can go to the code. Go to the code here. I believe that it should be in the include. Go to code here to include. Then we will try to grab have what? Yeah, what is it? Have architecture bug defined here. Okay, so I will grab this guy using the recursive grab. I don't know, and then try to grab. And I only find this kind of definition happens in the generic part, right? You have a generic architecture. Now, whether we have this defined or not boils down to the fact that whether we have this flag, okay? So then you can know that whether your architecture have defined this. And as a matter of fact, you cannot find anything, okay? So this is about the questions that someone asked, okay? Then what we do last time, okay? We basically do the following. We define a system call, okay? This is the definition. I don't know why I think it's again Windows sucks, okay? But this time it's not Windows sucks. It's Microsoft, okay? The bigger family sucks, okay? I use the Mac Office, okay, to convert my PDF, okay? Then it's originally it's a PowerPoint, right? After the change, okay, the color is correct. We have underline, we have color, but I cannot click it. Okay, yeah, let's see. Yeah, this Microsoft sucks this time, okay, or Office sucks. Okay, I cannot click it. Okay, I set all the links and then find out, oh, what happened? Okay, yeah, so I have to do it manually. Okay, so last time we go to this file, I remember that you go through this. No one get it wrong. Okay, no one get it wrong. And then here is to put down the function prototype. Okay, you define a function, what the function should look like, how many variables for the parameter, what is the return type. You all define all the things, and this is the function definition. Okay, you define the functions. You may have several questions. Hey, what is the sy.c? Yeah, let's go to there to take a look. Okay, so what is sy.c? Use the latest kernel, maybe latest kernel. Then go to kernel, where usy.c, sys.c. Okay, here. Okay, go in. And let's find, well, I believe that this is a bunch of code. If you want to understand what it is, usually I will do this. Okay, this is my habit. First of all, I will look for the keyword assembly language. Okay, so why I look for assembly language? Because I want to see whether there are any system call defined in this file. You find none. Okay, so there's no system call defined here. Okay, so one of the things is some static thing, and then we have the first kind of a define of a system call using another way. So what is this called? Set priority. Okay, we don't know. Then do a man page search. Man this. Okay, then you find that, oh, actually there's a system Linux man page, and said that there's a system call, and the system call is to set the scheduling priority. Okay, we will use it in the next lab. Okay, next lab workshop, I will use this kind of call to change the behavior of the scheduler. Okay, so this is one way to change it, and you will find a trace already inside the system sy.c. Okay, so the sy.c seems to be there's its partner, get priority, seems to define a lot of system call. Okay, get, what is that? regid. Very hard. What is this? Big comment here. Oh, unprivileged user. Oh, real GID. Okay, yeah, I'm real effective GID. So what's that? I don't know. Okay, set user. I don't know what it is. Okay, so basically there's a bunch of things that define here, and you are told that go to the bottom. Wow, bottom is a long way down. Okay, and here after this include your new call. Okay, so when you look at it, you will understand that, okay, we can define system call there. Why? Because we originally knows that this code will eventually generate other system call, and in your journey in doing your assignment later, or you as a hobby, okay, you want to include a new system call or modify existing system call behavior, okay, you are welcome to change any .c file. Usually .c file can you can find system call definition. Okay, then go to add a new call there, and this is the look. Okay, here's the look of the table that last time you added. Okay, and this is only defining whether it's 32 bits or 64-bit system, and the name of the export name and the real name inside is kernel code, this sys underscore thing. Okay, then we can find a system call table. I cannot click on it, okay, but you can understand what it is. So what is that? It is a table which is an array. Okay, this is an array that contains the entire system call. Okay, and you know what? It's very interesting. Back in version 2.2, okay, so even number means a stable release. I didn't explain to you guys, right? This number doesn't mean anything. You know, this number starts to go crazy. We originally have 2.6, and suddenly go to 3, and then now it's 4. Okay, but this number makes some sense in the past. It means even number, stable release. Odd number, developer release. Okay, or developing or buggy release. Okay, so that's why the 2.4 and 2.6 before there is 2.2. Okay, they are doing something really interesting. This is table, okay? We call it sys underscore table, and this table is just an array of function pointer dividing every system call. And what is the interesting thing of 2.2 version? You can write a system call, right? You include new system call, and that system call can access this table and update it. So what is the result? Result is there is an attack called very old attack called Linux modules exploit. Yes, also missing. Yeah, local root exploit, whatever exploit is the way to modify that table. Ask you to or cheat you to install a driver. Okay, actually driver is a part of kernel code. Install a driver, so that's why I said it's class discussion here. And the driver actually will modify this guy. How they modified it? Okay, they will hijack your system call behind ls. They will hijack the system call behind showing the processes. So what is the end result? The end result is to implement something called rootkit. How many of you know what is rootkit? How many of you have heard of this? Only one. What is that? Don't know. What is that? Huh? Yeah. And you can read that fast? Yeah, basically what is that? This is a kit for, not a KID, it's a kit for hacker. Okay? And you load it, and the ending result is you can launch a process, but PS cannot find it. You can install some bad files, but ls cannot find it. Okay? ls cannot show that file unless your code is rootkit defined system call. Okay? Then you can review that file, review that process. Basically, it's a hiding procedure. And a way to hide it before, okay, is to change this system call table. Okay, so original way is like this, okay, which is a legitimate. Now it's not. Okay, now it is being banned. No one can modify this table. If you try to modify this table, you will fail and get kernel panic, or not kernel panic, maybe we call it kernel ops. Okay, so what is kernel ops? No one heard of it, right? Last time I tell you to write several things. Okay, one is a stupid call. One is terrible call, right? Terrible call is panic. Stupid code won't panic, but you know definitely there is a bug, right? We call that kind of bug kernel ops. The kernel ops. They're really ops, okay? It's called Linux kernel ops. Then suddenly, oops, we find something bad, okay? And dump all the variable out, okay? And yeah, a programmer, you fix it, okay? And then it's called kernel ops, okay? So kernel panic means your program die, your system die. Kernel ops still okay. I kill your process. Okay, so we call kernel ops. And when you try to modify it, you will enter kernel ops. Okay, and this is already protected, so we cannot modify anything. And then this table, last time you modified it, okay, and every time when you modify this, okay, you will end up in one very bad experience. Is the compilation time takes 30 minutes. Okay, so why is that? the make file of the Linux kernel is like this. It will look for who are the dependency, right? I have a C file. Let's say I have C file contains syscall.h. That means I depend on it. Then whenever you find such a dependency happen and you change that .h file, you need to recompile that .c. Okay? So how many .c file will rely on it? Okay? So I don't just grab .c, okay? Syscall, what is it? Syscalls.h. Okay? I just do a grab over the entire system, the entire kernel source code. Wait. Yeah, see? It's kind of don't stop, okay? So I pipe to WC. Yeah. WC is not toilet, okay? I'm not sending it to a toilet, okay? I send it to word count, okay? To count how many lines, okay? Yeah, it takes some time. Later when we come back, I think that we will get the results. Okay, so basically it will kind of recompile entire kernel again, and that's why you need so many times. But if your change is only on a .c file, then it's better. You just recompile the .c, and if any file depends on that .c. So later when you try to do your assignment 1, okay, make sure that you don't touch any .h. And when you need to touch the .h, do it once. Then you will only have one time compile 30 minutes, and other times less than 1 minute. Okay, less than 1 minute because very few file depends on this guy. Okay, let's see. 300 something files depends on this .h. Okay, and I didn't stop here. Take a look at those dependency. Some of dependency is .c. You will find some other dependency is .h. So if it is .h, that means that it is just a linked list. Yeah, you are actually changing the entire kernel, so that's why you need 30 minutes to recompile everything. Okay, and then we have the user program. Okay, so what is the user program? You enter the user program and do some modification, right? You are not directly calling a system call. You use the call called syscall, right? I don't know whether you remember it. Actually, there's a way to call system call. Let's try this program. You can try together. Okay, I do a copy. And then have a terminal. But you have to inside Linux. Don't compile it and run in your Mac. Okay, it won't work. So this is my Linux. Okay, I go to temp, and then I should have that program already. Test.c. Let me make the font bigger. Can you see this? I just call get PID using this way. Okay, I call exit. Okay, but I forgot the parameter. Okay, so I added it. For parameter, I call exit with parameter 0. Okay, then compile it. It won't complain and run. It gives me the PID. Okay, and terminate the program. So this is another way to call system call. Okay, and that's why Helen showed you the code with this syscall and with a name that you define it. Okay, and actually that is the number of the system call. Okay, and this is the end of the debriefing of the previous test. Okay, today we don't have big class. Okay, and also we don't have a big test. Very good. So the task is I teach you what is a generic linked list, and you finish a short exercise. So what is the exercise? The exercise is in a GitHub. I want you to do like a simple data structure course assignment. Okay, I leave some blanks here. You try to add the element, print the element, but with some strange call. What is that? What is it? List for each entry, and then blah 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 blah. They are the calls from the library. Okay, and now let's take a look what is a library. Now make sure that you have to know what is linked list. Who don't know what is linked list? Good. Yeah, some people will tell me that I know linked list, but I don't know how to write it. Yeah, which is good enough because today I will clean up your mind. You don't need to know what is the implementation of linked list, because the old implementation that data structure course tell you is wrong. This is the masterpiece. Okay, really a masterpiece. Okay, so where can you find it? Actually, it is in the Linux kernel, and in the kernel Linux include Linux and the list.h, and you cannot directly use it because it depends on other kernel codes. So I extract it and make it become a portable .h and put it in the repository. Okay, so make use of that. Basically, I copy most of it. I just change some header files, so on and so forth. And you can find other data structure in the Linux directory as well. Okay, so what is the design of it? And how many of you don't know what is the design? This is the design that your data structure course teacher should have tell you, right? If your data structure course teacher tell you another thing, tell me. Okay, now you understand? Make sure you understand. If you don't understand it, you have a big trouble. Okay, and this is the basic design. But with this design, we have a big problem. Can you recycle the code that you write for the linked list? Let's say the insertion, the searching, the deletion. Can you reuse it? It seems not, right? You cannot reuse it. Okay, so the kernel don't want to have this. Okay, we have to build a library, linked list library that we can reuse. And still, it is a linked list, not C++. Yeah, C++ will build it. Oh, use vector, okay, or use whatever things you can think of. But this is not the case in C. Okay, and how can we build a software that can be reused? Okay, and yeah, I cannot hear you.
What do you mean by it cannot be reused?
Very simple. Let's say my addition of that linked list. Let's say I have this field. This is the key field. Let's say it's an integer. Okay. Now I want you to search for the list again, but I change the type from integer to a string. Do you need to change all of the operation? Yes. Searching operation, you have to change it. The creation of a list, you have to change it. All things you have to change it, right? Then can you reuse it? Basically, no. Okay, and kernel have a way to implement it so that you can reuse it. Of course, the searching have to change, right? Because I say that originally it's integer, now you change it into a string. Of course, you have to change something, but the change is not on the library. Okay, it's on your own code. So they separate something, and how do they separate it? Basically, they create a set of operations, like add to the head, add to the tail, or searching, but common to two different types, right? You have a common function that I call it add head, okay? And I can insert the two different data types onto that function call, and they both works. This is the goal. Understand? And when you think of it, is it possible? In C, it seems not, right? Unless you use pointer, okay? This is the code. Let's say I write it down here, if you can see it. Let's say I add head, okay? And I have the prototype. The prototype maybe here is the list itself. And I want to add, maybe this is a new node, okay? The new node, let's say. Not the new keyword, C don't have new, Okay. Yeah. Don't tell me that C have new. No, C C++, okay. Yeah, C don't have it. Okay, so there's the new node, this is the original list, I want to do this. Now, how can you do it in generic way in C if you want to? Here, they belong to two different types. You cannot do it, right? Unless this is a pointer. Unless it's a pointer. Then you can compile it, but with warning. Okay, they will tell you, oh, you are having two mismatched type, but yeah, in Cantonese, 吹咩? Yeah, we both are pointer types. Okay, we both are pointer types. You cannot resist me, right? And here also we need to set it to be a pointer type. Okay, and well, this seems to be working. Okay, but in kernel, the kernel implementation is going beyond this level. They don't implement it in this way. Okay, they don't want to have warning, right? When you go through the entire kernel compilation process, can you find any warning? None. Zero. Okay, zero warning. So this is also my goal. Okay, I wish that I really doing this. Okay, usually I write a program, I will try to minimize the number of warnings to zero. Okay, I mean, this is the good way, right? I don't know in your program, right? Usually your program with 2 pages of warning, and you don't care of it as long as it work, okay? Yeah. Kernel don't think in this way. Kernel programmers say that no, I put 2 pointers in. I don't want to have warning. Okay. So their solution is not changing GCC. Okay. Now change GCC, then no warning, good. Okay. Or turn off the warning. Yeah, bullshit. Okay. Yeah. Their implementation is very interesting. Okay. So the set of functions put inside there. This is the way their implementation is so interesting that they treat your mind. Don't treat your mind, twist, okay? Twist your mind. When you twist it, you define the data type, your data type, okay? And what is this list head? This is the kernel generic linked list implementation. You define there is a field inside your linked list, okay? Your linked list type. Let's say it's called a struct list head, okay? And with a name called list. Then what it will create something like this. Inside your structure, you don't have pointers. Very good, you hate pointer, I know. Okay? And you are being played by pointer and loss. In this list data type, you don't need any pointer. The kernel data type API will handle all the pointers for you. You include that thing inside, and the kernel will create a list just like this. And if you want a big picture, I already include a big picture here. Your data type don't have any pointers, and the kernel will set up the pointing things inside your structure. Yeah, it's inside your structure, as if you have 2 previous and next pointer. Okay, so this is the idea. And that's why when they call the functions, they won't have any problem. They won't have any problem because they use the same type. No matter this is your, let's say, a struct mode, okay? This is called a struct hi, okay? 2 different struct, okay? Without any problem, because you will input that field with the same type, okay? But does it work? It seems not working. In your mind, if not working, why? Let's write it down here, okay? Because this is a very interesting design here. Your way of thinking is like this. Because the first time I learned it, I also have this problem. You have a structure here, right? You have a field number 1, field number 2, field number 3, and let's say the kernel linked list is field number 4. Okay, so this kernel linked is field number 4. Now what is the problem? The problem is I can establish this list. Okay, after I establish this list, I will use this list to the next and the previous to transverse from this node to another node. This is clear, right? I need to transfer the list, or I build this for what? Okay, I need to go from one node to another node. Now the problem is, if I only have this 4th member, how can I access back to the member number 1? Yeah, this is the problem, right? I cannot access back to the other members. I can only play with my own members. Okay, and kernel uses a very beautiful way to solve it. Okay, now this is a definition. There's definition in this example. Okay, I use just 1 integer, and my goal is become simple. I want to have this list. To establish the list is easy, right? You know that, oh, using pointer. Okay, but can I access back the data here? Okay. And this is the core of today's talk. The core is this macro, this bunch of things. Okay? So what is this bunch of things? This bunch of things, basically, I tell you what they are doing first. What they're doing is, you have this list items in this location. It will use this to measure the distance between the top of your structure to the location of the member, we call it pointer. Measure the distance in terms of bytes, and use pointer arithmetic to bring you back to the beginning of the structure, and then you can start accessing the data again. Okay, so this is the way. Okay, and how they do it? How can they do measurement? You don't believe it. Very, I I have to say in Cantonese, so 变態, okay? So how can you explain in English, huh? 变態, I mean, insane is not at that level. Crazy is not crazy, right? Because this is a genius design. The genius design is, first of all, you don't believe it. It creates a null pointer. Okay, create a null pointer. 0 means null pointer. Do you know that the definition of 0 is null, or null is 0? Okay, create a null pointer and cast this null pointer to your type. Okay, cast this null pointer to your type. Why is that? I don't say anything yet. Cast the null pointer to your type and don't stop here and go to your member field. Go to your member field. Okay? So what is this operation? It's just, okay, as if I do a casting and try to access the field. There should be a segmentation fault, right? You have a null pointer and access it, but look at here. It don't want your here is the member, right? Let me show you how I code it. How I code it is I have to go to the code. Okay, yeah, let's stop. Okay, I don't go to code it. Basically, it's defined here. The definition. Oh, what? 800 something. Wrong code. Yeah, that's why I said Microsoft sucks this time. Why it point to wrong code? Sorry about that. I have to fix it. Okay. Then what is the point here? Actually, you are doing the casting. Okay, you do a casting and you don't access the field. What you are doing? You are doing something even more horrible. You define the type here. I don't want your value because once I access the value, I will get segmentation faults. I want your type. Do you know what I'm doing? Do you know what I'm doing? Okay, I will do it slow because we have a step-by-step show here. Okay, I actually define a pointer type. Okay, and constant type of. What is this? I have an example code. Don't worry. The example code is in our repository. Okay, the repository have a type of .c. Okay, so let's take a look. What is the type of .c? Why the indentation is like that? I hate Markdown. Okay, let me go to take a look at my terminal. Take a look at my terminal. Come on. Type of .c are still the same. Okay, I surrender. Type of good. Okay, so what is the use of type of .c? Basically, type of .c is when you input a variable. Okay, C compiler know your type during the compile time. Okay, and when you write in this form, let's say I define the swap functions like this. I put down the variable type. Of course, when you swap, two types should be the same. Okay, then I just pick A and put it here. Then it will become, let's say I define it A is integer. Here will become an integer. If I input CD is double, then it will become double. Okay, so let's try this. Compile. Yeah, no warning. Run. Yeah. So what is the power? What is the power of type of? Maybe you don't understand, huh? The power is that how many of you have heard? No, I just teach the elite class YouTube about this. You can define a macro to swap numbers. Okay, you don't need to define functions. You only define a macro, and then you can swap two numbers. But the hateful thing is you have to define the type here as int. Okay, it's like this, right? We can only say int. Okay, then if I change my type, okay, I want to swap to double. Or swap to, string cannot because they are pointer. Let's say the long, okay, unsigned in, okay. I want to change something, then I fail, right? Because inside the macro I hard coded, but the operator called type of can solve the problem. Okay? It will, based on your input, and create a type. And then you can invent a generic swap macro. Now you don't need to write any swap functions, except you're swapping to string. Swap to string I cannot help. Okay? And swap some basic types. Okay? Then you can do this. Yeah? So you understand the type of now?
Why do you use do while zero?
Good questions. Do while zero is a masterpiece. It's a piece of masterpiece. Okay? Really masterpiece. What is do while zero? How many execution you will have inside that while loop? Once only. Right? Do while loop, you will execute once and then go away. Okay? So the problem is this, right? Should I define this way or define this way? Right? They are just the same if you ask this question. Right? Are they the same? Yeah, ask yourself. They are the same. Don't get puzzled. What's that? They are the same, but what? But what? Or I should have asked you this question, right? Can you give me an example that version 1 is a lot safer than version 2? And the example, I expect you give me an example when you use the swap macro, you'll get into big trouble. Oh, go back a little bit, how to use the swap macro. Yeah, you have the swap here, and then this will become a copy and paste, put in this location. And I put down the semicolon here, then we'll have a correct compilation. If I miss the semicolon, what will happen? There will be what? That's right. If I miss the semicolon, okay, you cannot compile it, right? So I add semicolon here, then no problem. So can you see why I used do while zero? This is only one of the reason. Okay, then you can say that, okay, no problem. I change it to the version 2. That semicolon will place in here, and I give the programmer a bonus. What is the bonus to the programmer? Yeah, really bad bonus. Let me change this. Okay, remove the do while loop. And remove the semicolon. Oh, yeah. Still works. You like it? Yeah, that's a bonus. Yeah, you can write something without any correct syntax here. Okay? Yeah, you want this where I know that you already want to write something without anything trivial, and this can compile, and you can treat your friends and yeah, take a look at my C code. Why it works? Okay. Yeah. Why it works? Yeah, I remove semicolon, you can compile, right? So it seems that they are the same, right? Because I just want to enforce the use of semicolon here, right? Now here I will enforce the use of semicolon. If I put it here, you remove semicolon, then you cannot compile. Okay, so let's say my concern is not about the semicolon. Okay, if you can already get the idea of using semicolon, you are already very good, but not very good. The very good case is let's say I ignore the use of a semicolon here. Okay, and can you think of an example that if I use this call, the swap AB, okay, I will have a big trouble. I cannot even compile a program or run a program with some bugs. If I say that I don't use version 1, I use version 2. Can you think of a case? Yeah. I remember last year I put this into the final exam. I asked, version 1 and version 2, which is better? Okay, I talk about it, okay? So that's why all people know how to answer it. Can you think of any ways that when I call the macro, version 2 will give a very serious error.
When you use it in the if else statement.
Exactly. If else. If I use if else, I will have a big problem. Okay? So you want me to try? Okay. I guess you don't know what is going on. Okay. Yeah, his answer is if 1 equal 1, okay. Okay, so I don't have curly braces open. I just do this. Else, yeah. Like this. Do you think I can compile? You think I can compile? Who think yes? Who think no? Why don't you say no? Okay, thank you. you say that I cannot use it, okay? Go ahead. What it says? It says, else expression has something wrong, express something. What the heck is going on? Else has some problem. Okay? So let's take a look back to the macro. You write this, basically you are replacing this block. Replacing this block with this location, right? With that location. And I make it become a comment first of all. And replace it like this. Okay? But the replacement is not that. Because the replacement will only replace up to the closing bracket. You will put down a semicolon here. Okay? And then you will break your entire program. Okay? So how about the do while case? Do while case. Else. Make it become do while 0 and do. Okay? I still have this program. Let's try compile it. No problem. Because to see the do while statement with a semicolon is a complete statement and it's one statement only. So it works. Okay? So don't be surprised why I suddenly say that, oh, do while 0, okay? When you look at the kernel code, you will find many places using do while 0, okay? Because they write a lot of this kind of macro. They even want to, let's say, I want to enforce its execution only happen once, and blah, 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 blah reason, okay? You will find it in driver, you will find it in macro definition, so on and so forth, okay? You will find it a lot. So do while statement, very good. Yeah, you have read ahead, okay? So you expect I will talk about do while 0. Now, until now, I didn't explain anything about the linked list, but you already have a sense that actually you don't know how to write C. This is my understanding. I first look at oh, how this is constructed, and the first time I look at do while 0, okay, then I already have a sense that I don't know how to write C. Second, okay, is about the type of, okay. I think this is the first time you see type of. It also for me 10 years before, okay. I look at what is this type of, okay. Is it something new standard? No, it's not just new standard, okay. You can compile in a C99 standard already, okay. This is not the end, right? This is not the end. You know this is not the end, okay. Yes, you know how horrible this course is, okay. Yeah, horrible. Right? Now what is this, okay? Now, when I know an entire thing, it means that I just use this 0, okay, the null pointer, to access the member, okay, and make it become a type only. I just want a type, okay? So this is the how, okay? Make it become a type, and then you put down asterisk this. It means that I'm doing a definition, okay? I create a pointer, but the type I don't know. I don't know the type, so I depends on your input, okay? And go to the member field, okay? So what is the member field? Usually we will use the member field, the linked list type, okay? So you can treat this as a, oh, you're putting down a linked list here. Then what is the next? Any problem? It seems to be a little bit harder. So another thing is like this, okay? We do this just wish to create a pointer. That's all, okay? And when I have the pointer, then I will use this pointer, cast it to char. And why I want to cast it to char? Okay, I want to calculate the distance, basically. I want to calculate some distance. And the distance, how many of you have skipped first week tutorial, okay? There is a problem that Calvin asked me back, okay? Calvin says that some students asked him one question. The question was, when we have two pointers, integer type, pointer P and Q, okay? When they have these calculations, the return value is not a byte addressable thing. It means the distance between these two guys in this value, divide by that. So it means how many elements of integer between these two guys. Okay? And that's why we have this casting, to cast it to char. So when it becomes char, and I do change here, subtraction here, then it will become byte by byte measurement. So that's why the code becomes so crazy. I want a pointer, okay? I want a pointer, then it becomes a pointer, and it seems to be stupid. Why is stupid? When you use this macro, you are required to put down a pointer, and then assign that pointer to here. It seems to be stupid, right? You create a pointer by so huge effort, something you don't know, and that pointer is just equal to the pointer that you pass in. It seems to be stupid. Why we need it? Why don't we change it into PTR? I give you a break. I wish someone will answer me. This is a very, very, very clever design. Okay, that's why I say that after I understand this macro, I know that I don't know how to write in C. Okay, I don't know. Okay, I will stop for a while. So let's take a look at how kernel is using this, the list.h. So the container of definition is here. Container of is how we use it. How we use it. Oh, yeah. Okay. Where is it? Okay. So there is a call called list entry. I don't know what they are doing, but it's just redefine it called list entry. Okay. So I redefine it called list entry. Okay, so there's so many list entry here now. So many list entry. So the list entry is to do something, okay, do something here. And when you call it as if you're calling container of, and then assign the value to POS position. So this is the use, okay? The use is to generate an address and pass this address to here. Okay? But look at here. So many buts. This time we have many buts. What are the buts? This is not a function. Can macro generate return value? No. No return value, right? Can you find a return statement? No. If you put down a return statement, it will be disaster. You spell, you know. Yeah, get out of that. Yeah, you cannot return. You cannot even add return. So does it mean that this macro sucks? No, it's you sucks. You don't understand. Okay, it's even for me. Okay, I just learned about it several years ago. Okay, first time I read this macro, I don't even aware of this problem. I don't think there's a problem. Oh, it's giving an address, so I access it. Yeah, but think about it for a while. Where is the return statement? No, it's not a function as well, right? And the trick is. Can you see this 1, 2, 3, 4 characters in that macro? Take a look back. Can you find those 4 characters? Yes, you find it. What is that? Do you know what is it? You know, oh, bracket and brackets, right? Well, actually, what is the use of it? I know about it several years ago, and this is explained here. Okay, the explanation is, take a look at this program. What this program is doing, it is a for loop, right? A for loop, but calculating from, this is actually a factorial function. Okay, calculate the factorial and put the results into P. And I hope that I can finish this code and have the factorial results, put it back to the product as if the container off. Okay? Then the tricks come with here. What is this line 7? Now, first take a look, it's execution. Where is it? Now it's a block.c. Okay, I just define a factorial function, and I define it here, right? You can see the P here. And I can code it, let's say I want a factorial of 6. Okay, compile and run. Compile, block, run. Yes, 720. And look at the code again. Is it a function? No, it is not a function. But as the same as we have in a container of macro, we have these 4 special characters. And this special characters has meaning in C. When you enclose a compound statement, so this is a compound statement, right, or called block. When you enclose a block with a pair of brackets, it will generate return values. Yeah, you can generate return value. You know, a statement equals assignment statement have return value, right? Yeah, you already know it. But this bunch of code originally don't have any return value, and C allows you to do this by adding this and this. Without them, it doesn't work. Yeah, without them. Yeah, without the bracket, what will happen? Compile, fail. You cannot compile it. But add it back. Add it back, add it back. Works. And generate value. Yes? Semicolon, 2 semicolon, where? Oh, sorry. Yeah, remove it. Okay. Yeah, it still works. Yeah, I just added by accident. Yeah, it's not. Don't think that you're adding some tricks there. Yeah, I added by accident. Okay. Yeah, there's no tricks. Okay, no fool, no tricks, no games there. Okay. Yeah, this is something extra. Okay, so this bracket actually brings about a return value, and the last statement here is the return value. Yeah. So now you already have some knowledge to treat your friends, okay? Write a program, ask you, hey, what is this, okay? And he don't know what is it. Oh, because there are some hidden component in C. Okay? So that means that this whole bunch of things will calculate the correct results and give you this P value as a return value. And what is the magic? The magic is they are all temporary variable. I must say not temporary variable, but inside that scope. Okay, inside that scope, if you're outside that scope, okay, it's gone. Okay? As if you're calling function, and together, what this code mean? You understand. You're actually doing a pointer here, that has become very simple. You point it here, using subtraction, pointer arithmetic, cast it to top, bring you to this location, and with this calculation, treat it as a return value of this whole block. Return that address, and that address is here. What is the use? The use is when you have the entire structure like this. Okay, so this is the best practice. Okay, you can read ahead. In this area, I will tell you some anti-pattern. Do you know what is anti-pattern? Anti-pattern is the code are working, but the industry don't accept it, or people think that you are writing lousy code. It's called anti-pattern. Okay, so here is the best practice. You create a head type, okay, and in a head type you create a list head and form a linked list, just like a circular linked list. And whenever you try to access the data type, you use the library. The library use container of. Whenever you access this pointer or this, we call it a structure of the linked list, then you can retrieve back the data type. Every time you can retrieve back the data type by having this location. Okay, so this is the magic about this data type or API. Okay, so this is the magic, and this is the container of. Okay, and the container, I finished it. I don't need to say too much here. Basically, you will use this container of, and when you use the container of, you give me a pointer. What is this PTR? Can you find it? Can you find it? Do I make anything wrong? Here? Here? Yeah, I did something wrong. Okay. Yeah, I should I should copy and paste and change it. Sorry. Yeah. Okay. So create a new code. Yeah. Wow. Save to your test.c. What? 1 year. Yeah. This atom sucks. What happened? Atom also fails just because the code is too poisonous. The object container of. Okay. Okay. Return 0. Okay. So this is a pointer. This is an object. So this is the object. This is the object pointer. Okay. And the object pointer is equal to container of. Here is a bug here. Sorry about that. It should be the list pointer. Okay. So inside this data, I have the list item. So let's say I create an object. So create an object. Yeah, that's why you see I just typed the program but didn't run it. Okay. So create an object, and an object I just sorry about that. Again, one more bug. Yeah. Okay. Create an object, and then get the list pointer. And when I have the list pointer, I can use the container of to calculate back the start of the data. Okay. So let's run it, and you should see this equal to 1. Okay. Compiled. Test. I forget about this. Because I should have the program here. What is it? Is it offset off? No. Where's my program? Sorry, I have to look for it for a while. I should have that program. That's why don't do anything at 4 o'clock. It's a 4 o'clock task. Where is it? Container of. Yeah, maybe later I give you back the code. Okay. I don't waste the time in running this. Okay. Then I will ask you to do some practice, okay, using this linked list structure. So what is the linked list structure? How to use it, okay? Now this is the structure that usually we will create using this data type, the list.h, okay? We will have a head type, we will have a data type, and the head type is like this. This test. Okay, the head type is like this. I love to do is I know to count how big is the linked list. Okay, that's why I have to count here. For data, let's keep it to integer only. Okay. So this is the best practice, and every kernel data structure is aligned in this way. Okay. Then what are you going to do? You just do something very easy. Take a look here. I just dump all the things here. Let's go to the main. I want you to, let's say, like, initialize the list, okay, and initialize the counter to 0. And every time you add a new element there, print it and remove it. Now, something really hard to understand. Hey, how to add it? You've never seen this before, right? And the code is list add. So what is list add? It requires to give a linked list item of the new data and the linked list item of the head. Okay? So you will fill it here. Use the list add. Okay? But I know you want to know the truth. So what is the truth? The truth is how it's being implemented. Okay, very easy. List add. Oh, this is underscore list add. Okay, yeah, this is list add. Okay, it's just define that. Oh, this is the new, this is the head. Okay, you give me something that I will call some functions, and the functions is they implement all the pointer pointing for you. You don't need to worry. Okay, and then you will go to have the loop. Okay, the loop is called, this is an amazing macro. Okay, the loop is called list for each entry. Okay, and what is it? Take a look. What is it? What is list for each entry? This is for loop. Yeah. Someone warp the for loop and don't tell you, oh, it is for loop. Actually, it is a linked list transversal call. Okay, you can transverse the whole list. Okay, and what is the position, head, and member? Okay. So the list for each, okay, is already have a documentation, at least for each entry. Sorry, list for each entry. It's already have a documentation type pointer to use as a loop cursor. It means sucks, right? You don't know what is the sub talking about, right? The head of your list, or what is it? I don't know. The member of the list struct within the struct, okay? So many struct, what are you struct, okay? I mean, you need some help. So the help is here, okay? To transverse the list, you create a pointer, which is for it to transverse the whole list. And every time when you call this, actually you're calling the for loop. It will give you a new item. Okay, you point to the start of the new item, and then this is the head. Okay, oh, sorry, I should type head. Okay, head here, and then you specify within the structure what is the name. What is the name of this item? I call it list. Okay, I call it list. So when you call it, you will write down list here. Okay, so this is a for loop, and the for loop, look at it. It's actually doing something crazy. This is actually equal to container of. It will try to use container of the position, start with the head pointer and the head next. What is the head next? The head next is, this is the head. Head next, maybe this is head next, this guy. Okay? So go to this guy, and the position pointer, you don't need to care about what they are. So basically they are getting the type, okay, the type pointer pointing to the start of the first element. Okay? And then continue to go to the next item using this position member legs. Okay, go to the next. And until it reaches the head again, it will stop. Okay, so this is the very easy thing. Okay, and tell you one thing more about why I love this data structure. There is one more call. It's called list for each entry safe. Yeah, there's something not safe. What is the thing that is not safe? Okay, let's take a look what it is. Okay, it's asked you for extra pointer called n. Okay, so when you use it, how you use it? You use it in, did I write down this for each entry to save? Ah, no, I shouldn't. Ah, okay, I've what happened to me last night? That's why I don't do anything in 4 a.m. Yeah, I have to change it. Okay, how can I change it? Wait for a moment. I